Welcome to module 1 of the unit Determinants and Matrices, and in this module we'll be introducing what are matrices, okay, and then we will go to determinants. Now what are matrices, or in singular a matrix? A matrix is a rectangular arrangement of numbers into rows and columns, okay, a single matrix and many matrices we say. Okay, say for example, if I have this, okay, this is an example of a matrix where I am putting this numbers 1, -3, 2 and 0, 4, -1 in rows and columns. I have a row here, another row here, a column, another column, another column. Basically I have 2 rows and 3 columns. So rectangular arrangement of numbers into rows and columns. So here I have put another rectangular arrangement here. So I have 1, 2, 3 rows, okay, and 1, 2, 3 columns. Rectangular arrangement of numbers into rows and columns. This also I have here, I have 1, 2 and 3 rows, numbers in 3 rows and 4 columns. Matrices are denoted by capital alphabets, okay, like capital A, capital B, capital X, capital Y. So if I have to say that the first matrix here is matrix A, I would say matrix A is equal to this. If the second matrix here is referred to as say matrix B, if I want to denote it, I would say matrix B. I would write capital B. If this third matrix is say matrix X, I would say capital X. Capital X is equal to this. So we use capital alphabets to denote matrices. Okay. Now what are matrix dimensions? Okay, the dimensions of a matrix tells its size, the number of rows and the columns of the matrix. Okay. So if the matrix has m rows and n columns, we say that the order of the matrix is m by n, or m cross n, or we say the dimension of the matrix is m cross n. Okay, so if I have something like this, I may have say one row or a 2 row or a 3 row and so on. So suppose I have say m rows like this, and then I have a column, another column, another column, and like this say n columns. Okay, so m by n matrix will look something like this, in which there will be m rows and n columns, and there will be numbers here like this. Each row and each column will have numbers. Okay, so if the dimension of the matrix is m by n, we say m by n here, something like this. Okay, and there will be numbers, arrangement of numbers here in each of these positions. Let's say for example, if I say I have this matrix here. Now this matrix here has 2 rows and 3 columns. It has 2 rows and 3 columns. So I would say the dimension of this matrix is 2 by 3. The same way, if I consider this matrix here, the same matrices that we considered earlier. Now this has 1, 2 and 3 rows and 1, 2 and 3 columns. Okay, so I would say the dimension of this matrix, or the order of this matrix, is 3 by 3. We always write down the number of rows first and then the number of columns, okay, in the sequence like this. Number of rows is 3, number of columns is 3. The same way, if I have this matrix, I have 1, 2 and 3 rows. So it has 3 rows and 1, 2, 3, 4 columns. So this is a 3 by 4 matrix. Okay, dimension or the order of this matrix is 3 by 4. 3 rows and 4 columns. And each of these positions has some numbers assigned. So these numbers inside this matrix are called as the elements. Okay, so each element in a matrix is identified by naming the row and column in which it appears. Okay, so if the element is in the first row and the first column, okay, it will have a position like 1, 1. Okay, A here refers to whatever is the real number or the number that is assigned here. So if the number is in the first row and in the second column, okay, the first row and the second column, so it will have a position that is assigned to it, which is 1 comma 2. Okay, the same way first row third column will be 1 comma 3 and so on. This is like first row and the nth column. Okay, here this element is in the second row and in the first column. This a2 comma 2 is in the second row and the second column. The first value refers to the row and the second value refers to the column in which it is present. So like this, here this is mth row and in the first column, so this is m comma 1, the position of this. This is mth row second column, mth row third column and so on. The last one is mth row and nth column. The dimension of this is m cross n. So let's say if I have this matrix here, I say matrix A, which is here. So this 5 here is in the first row and in the first column, 1 2 3, and I have 1 2 3 4. So what is the position of this 5? It is 1 comma 1. What is the position of this 0? It is 1 comma 2. Position of this 3, it is 1 first row and the fourth column, so 1 comma 4. What is the position of this 2? It is 3 comma 3. This is 3 comma 3. What is the position of this 8? It is 3 comma 1 and so on. So each of this value, the number in the matrix, has a unique position that is assigned to it depending on which row and column it appears. Now, what are uses of matrices? Of course, matrices is widely used on almost all the fields. Some of the uses that we usually see in one of the most important is its use in solving a system of equations, which is widely used in almost all the fields. Okay, so it is used in solving a system of equations. In fact, if we can use some softwares, then using this matrices, like how MATLAB uses in solving a system of equations. Okay, there are some softwares whose foundation is matrices in solving a system of equations. It is also used in linear programming to determine the most profitable combination of ingredients in a product. Okay, this is more of a business oriented. And a matrix is also used in structure, organizational structure in a company, in reporting relationships. Okay, and it is preferred rather than using the conventional methods. It also helps a company in visualizing the interconnected relationships between various departments. Now, specific to business, how matrices are used is it is extensively used in decision making process, to calculate maximum profit over a set of restrictions. It is also used in risk analysis and so in portfolio management. It is also used in force matrix plan or ladder plan to highlight the compensation benefit flow across the hierarchy. It is used in inventory problems. This is something that we also use in operations research and transportation problems. So some of the applications of matrices in business, of course, not restricted to this, matrices is used in other fields as well.